Welcome everybody to today's ViZn Energy webinar on solar nights, utility scale solar and wind power for less than coal. My name is Matt Barber and I'm with Mercom Capital Group. I'll be moderating today's session and will introduce our expert presenter. First, just some quick housekeeping. Know your microphone is not broken. All attendees are on mute to make sure everybody can hear the presenter clearly. You can use the questions panel on your toolbar to type in questions at any time during today's presentation. We'll answer relevant questions as we go through the presentation, and we'll also hold a short Q&A at the end of the webinar. We are recording, and we'll send out a link to all registrants after the webinar today. Speaking of recordings, all of ViZn's previous webinars are on the website at the address below. Please do go view them when you have a chance. We've had 6 very interesting sessions over the last year. But in particular, if you have any questions about ViZn's technology, go watch Flow Battery 101. It's one of our most popular sessions. It was presented by ViZn CTO, John Lowell, and it gives a lot of really good information. Today's presenter is ViZn Energy's Vice President of Marketing, Mike Grunow. Mike has over 15 years of experience focusing on clean tech technology with companies such as GE, Trina Solar, Moventus, and now ViZn Energy. Mike, the floor is all yours.
Thanks a lot, Matt, and thank you everybody for coming. Like Matt said, this is our 6th webinar, and as I'm scrolling through the attendee list, I see a lot of familiar faces, but I also see a ton of new faces because I think we're striking on a subject here that is near and dear to a lot of people's interest and passion in terms of what the long-term asymptotic cost for not just renewable energy, but how do we start to think about how we pair it with large bulk storage for transition to significant penetration, way over 50% in terms of renewable energy on the grid. In terms of our agenda, we're going to start it off with how solar or wind plus storage can still be cheaper than coal. And we're going to transition, and I won't go too deep, but I do want to make sure I hit in the first 10 minutes a little bit on a background of ViZn technology, our key value proposition. Then I'm going to shift into what I think is a real seminal moment here in kind of what I would say is the last 20 years of the development of bulk renewable energy, and that was the Tucson Electric Power Next Era Energy announcement. And it was really the genesis for kind of the economic exercise that ViZn went through in and around the Solar Nights math. And so we'll go deep into the Solar Nights math. We're going to do a sensitivity study and then take a look at what one could do with the second cycle of the battery overnight. And so Solar Nights is going to quickly evolve in this presentation into something called Solar Nights Plus ancillary services, which could bring you actually from 4 cents down close to a number that's in the low 3s or even sub 3s, depending on what ISO and utility environment you're operating in. And lastly, before the Q&A, we're going to bust one myth on lithium-ion versus flow batteries, and that's going to be footprint, and we'll go from there. So please feel free to submit questions along the way. Look forward to addressing as many of them as we can. And again, we're always here to address any project-specific questions you may have after the event. So this is a very recent graph that came out by Bloomberg, and you know the levelized cost of electricity of coal is hovering around 6 cents now, and it looks like it's not going down, and these numbers are independent of any type of cost of carbon. And the solar and wind numbers now are independent of any production or investment tax credits that could lower them for specific North American tax treatment and economic treatment. And so I dropped that little picture of the battery in there because the spread on the renewable energy shaded areas basically takes into account high solar irradiation, low solar irradiation, high wind speeds, class 1, class 2, class 3 wind sites. And you know the key point I'm trying to posit here is that batteries aren't going to break the bank, frankly, when it comes to shifting to way over 50% clean energy as part of our mix in the near term. And so there's enough headroom in here in terms of affording the batteries. The general theme, right, is that clean endless energy no longer comes from the ground, it comes from the sky, right? The cost is down 40%, it's dominating annual new installs, but it's got this baggage, right? And we all know it. We all know that, you know, the old adage, when the wind isn't blowing or the sun isn't shining, what are you going to do, right? And like many of you, I spent my last 15 years working in either wind or solar or both. And I jumped over to the storage industry after doing a ton of research on the technologies, the competitive landscape, and I feel like I brought a good understanding of what types of batteries are the missing piece and what are utilities actually looking for, and I hope we'll go into that today on this webinar. I'm not the only one, right? This is a recent study out by Navigant, basically forecasting that over 150 billion of large utility-scale stationary projects will be made in storage over the next 10 years, with the countries listed as being the key markets where 2/3 of the demand will go. So, you know, this isn't you know, ViZn's idea, this idea of solar nights. This is a global macro trend coming from not just manufacturers of novel technologies, but also thought leaders and industry consultants that have essentially been proven to be right over the last 20 years of developments of renewable energy utility scale economics. A little bit on ViZn. I'll try to keep this short because I don't want this to be an infomercial, but we're a 10-year-old company. We've had systems in the field for almost 4 years now. We actually have and have shared two significant, and will share with any company and any customer that wants to take a look at them, two significant third-party independent engineering studies with leading companies like TUV and Black & Veatch. We're actively building the largest flow batteries in North America, Central America, India, and Europe right now. We've announced all but one of those systems. We have significant field data, and also we've built a tier 1 EPC and balance of system ecosystem where, you know, any entity, whether it's a developer, an IPP, or a utility, or a large industrial client, or even a municipality, when they approach ViZn, we have the wherewithal within our network to give you a turnkey bid for a bankable system within 7 to 14 days. We'll talk a lot about 20-year battery system economics. I think to the extent that folks have been essentially learning about energy storage based on lithium ion, the 20 year is going to be really an eye-opener because lithium ion is really focused on 10 years. Our system is based around its heart, which is the battery stack. It's been in development for 10 years. We have over 90 design iterations into it, significant amount of IP. It's the 3rd generation of this technology. And we produce it together with Jabil, our manufacturing partner. They're the 3rd largest contract manufacturer in the world in their ISO 9001 manufacturing facility. In addition, we've had systems for over 3 years in the field, several of them collecting significant data, developing megawatt years of learning and field data, and all of that's packaged into our technology that has gone through significant testing and third-party vetting, in addition to what we illustrate here is over 1 million of high-frequency power switching cycles that essentially emulates over 27 years of PJM cycling in a very, very tight, constrained time frame. It's not just ViZn. Like I said, when we come to market with Jabil, our manufacturer. Our balance of plant is all fully integrated ahead of time with Schneider in terms of controls and power conversion systems. We have additional controls partners like IHI, who are industry leaders in both large industrial and front-of-the-meter systems. And then when it comes to actually installing these systems, whether it's a large industrial, municipal, or utility scale system, we have a bevy of partners who are on the ready, on the go, not just in North America, but also in Central America and Europe and Africa and India, who are able to support us and support our development partners going forward. Why are all those people so interested in ViZn? What they're finding out is that the 20-year battery economics are important, and we have a low first cost, we have a low OpEx, and in a highly differentiated manner, we're able to show up and deliver both power and energy systems and energy services from one platform. So if you look at this slide, the area in the middle is directly out of a Samsung brochure. When you go in to size a lithium-ion system, you have to choose whether it's going to be a short-duration power system for ancillary services or whether it's going to be a long-duration energy services system for things like energy shifting or curtailment. And if you go to use a lithium-ion system that's sized for power to do energy service or vice versa, that system is going to invalidate its warranty, and you're going to end up with a lithium-ion system that only lasts, between 3 and 5 years in the field. The ability to actually perform high-power services across the complete state of charge with a duty cycle that has negligible impacts on degradation is a huge differentiator from ViZn. And as we see later, when we look at Solar Nights Plus, we'll begin to see how the stacking of these power and energy services can lead to anywhere from 30 to 50% more revenue per megawatt per year.
Hey, Mike, quick question. Can you explain why lithium-ion systems can't perform energy and power in one system?
No, that's a really good question. The fact is that in solid-state chemistry, the chemistry and the components and the HVAC systems and the structure of both the leads and the separators within a lithium-ion battery pack are engineered for either rapid discharge or slow discharge, right? And so, the buildup of the thermal stress and the migration of the chemistry over time is all designed for a particular use case and application. And so you have two very different engineered systems when you're buying lithium-ion modules. And so I hope that answers your question. So in addition to power and energy versatility, the ViZn system is a 200 on the NFPA scale. That basically means that our system is non-toxic, non-flammable, non-explosive, and the feedback that we're getting from the market is that this helps significantly with siting, permitting, insurance, and transport. In addition to being able to go basically anywhere right up against where people live, work, and play, or near high-value grid infrastructure, the systems have zero HVAC. So we're building some systems right now in India, and these systems are going to be in high temperatures, well over 100 degrees Fahrenheit for more than 6 months out of the year. And the system architecture has no air conditioning, right? And so when you start to look at the impacts of these types of auxiliary loads on round-trip AC efficiency, you start to see a balancing of the economics. And one of Black & Veatch's key conclusions was that our system should outperform lithium-ion systems in warm climates. We're almost done. We're almost into the Solar Nights piece, but the last piece on ViZn, this is just looking at our key product features and benefits compared to the incumbent. We got a 20-year system compared to a 7 to 10-year system. We're able to deliver power and energy applications and services from one platform as opposed to having to pick one early on in the development cycle. It's a safe, non-toxic chemistry that basically allows for simplified siting and permitting, and our ability to do 2 cycles a day and power and energy applications leads to up to 1.5 times the annual revenue per megawatt when compared to lithium-ion. So that's the background. I know you guys all came here for the open kimono Solar Nights economics, and we'll go there right now. So this all started with the announcement on May 23rd of Tucson Electric Power signing a power purchase agreement with NextEra. 100 megawatts, 30 megawatts of 4-hour batteries, 4.5 cents over 20 years. And the assumption is that Tucson Electric Power has the right to dispatch the battery to best meet their needs. It's our expectation that this is done primarily for energy services, that this is done to meet capacity in the late afternoon. The assumption is that it's done with lithium-ion modules and a COD of 2019. Frankly, this is the largest deal like this ever done, and it's the lowest PPA rate ever signed for a hybrid system like this of utility scale solar and storage. And so it got my customers, it got the ecosystem, it got the entire solar community and even the wind community kind of really curious. And in ViZn, we said, well, that's real interesting. Could we do better? So we opened up the financial model and we built the underlying assumptions for the Solar Nights campaign that we'll get into. And we think that we have a pretty interesting value proposition and look forward to walking you through it. Before I walk you through it, I think it's really important to think about, what is Tucson Electric Power interested in with a lithium-ion system attached to a solar farm. So the graphic on the right, on the top, is the delivered energy heat map. You can see the 12 months of the year in the column and the 24 hours of the day. And so this is the typical output of a one-axis track solar system throughout the day. You can see that the production sort of starts around 9 a.m., tails off in the afternoon, and you look at, like the duck curve in California, or you look at any major utilities load profile, and most utilities actually have a load profile that peaks in the morning around 8 to 10 a.m. and peaks in the afternoon from 4:30 to 8 p.m. And so you have this issue with solar where you've got excellent low-cost kilowatt hours, but they're being delivered in the middle of the day, which as solar penetration increases, can lead to the requirement for curtailment or shutdown of other thermal assets. And so shifting that energy to the afternoon using the first cycle is a cost-effective way to provide ramp and evening capacity. But I think that's just half the story, because I think when folks are thinking about solar and storage, this is the primary application they're thinking about. As we get into Solar Nights Plus a little bit later, we'll be talking about grid services, frequency regulation, voltage support. These are also important to utilities, and right now they're currently being provided by thermal assets, and they're being provided at relatively attractive rates. These rates alone are not enough to pay for batteries in most ISOs and utility territories, and so the combination of using utility scale solar plus storage for its first cycle to do a capacity service like you're looking at here in terms of meeting the ramp with peaking capacity by shifting the energy, that's a great application for the first cycle. But ViZn's very unique in our ability to do that second cycle overnight. So we'll start to look a little bit later about the upside from the second cycle. So the economics, what did we assume? We picked the same year, COD, same location, Arizona, and the same assumptions, basically burdening the solar project with the CapEx of adding the battery. Just like the TEP system, we made the same assumption about dispatch for a cycle a day. Solar, we have at 85 cents, which I believe is right in line with what we're seeing in terms of 2019, subject to the 201 trade case that's ongoing. Battery CapEx for ViZn, we assume $375 for the system, turnkey, and that's in line with our pricing and what we're seeing from our partnership. Solar capacity factor, very, very important here. The assumption for the ITC is also very important. We'll understand its sensitivity in a little bit. And important that for the 4-cent PPA, we assume zero ancillary service revenues are modeled. Okay? And we've dropped in a 2% escalator on the PPA. And it's important when you look at the impact, and we'll circle back to this later, when you look at the impact of dropping a 30 megawatt battery for one cycle on a 100 megawatt solar system, the 30 megawatt battery can hold about 120,000 kilowatt hours if it's a 4-hour battery. That's about 20% of the output of the plant. So 80% of the plant on a daily basis flows right directly to the grid. And whether it's the lithium system or the ViZn system, that system is going to be charged by the solar in this case, and it's only going to take about 20% of the overall plant output to charge it for one cycle. All right, so here's a sensitivity analysis, and you'll recognize this nice round number at the top, which is 4 cents a kilowatt hour, but that's not the Solar Nights campaign 4 cents a kilowatt hour. That's the PPA needed for if you just built 100 megawatts of solar in the same location with no battery and no ITC. That 4 cents is what you would need today to hit the same type of unlevered project returns. Then, if you were to go drop a 30 megawatt battery with no ITC on that project, you wouldn't need 4 cents. You'd be burdening that project with significant CapEx, and that would bring you all the way up to 6.2 cents. Now, you take that first row, that 4 cents, battery, no battery, 100 megs of solar, and you apply the ITC, and you get down to 2.6 cents, and then you start to do the walk, adding 10, 20, 30, and then 50 megawatts of battery, and you can see the impact that has on the required PPA to hit the same target return, right? The battery is just being treated like additional balance of system cost in these assumptions, right? Now, it's interesting. So the 4 cents, 100 megawatts of solar, the 30 megawatts of battery, the ITC, that's the base case. It's interesting that that now with the ITC is equal to the PPA with no battery. But what's even more interesting to me, because my first question when I saw these numbers was, well, why wouldn't I just build the solar and forget the battery, right? Well, the interesting thing is when you start to think about Solar Nights Plus, which is adding in ancillary service revenue, you start to see, depending on your assumptions and depending what type of merchant risk you're willing to take, you start to see opportunities for getting the 100 megawatts of solar and 30 megawatt battery with ITC and ancillary service revenue back down below where it would be if you didn't put a battery on it in the first place. And it's an interesting walk. It's an interesting set of assumptions. And so we're gonna dive into that in the next 10, 20 minutes. So the first thing that we're going to look at is all-in system costs, right? And we have what I believe is one of the better vetted all-in turnkey system cost models in the business. Like I said, we work very closely with 5 or 6 EPCs in our ecosystem, and they give us constant feedback on this model, and it's constantly being refined as we look at different types of projects all around the world. So I apologize, this is a bit of an eye chart, right? But what makes up the 375, right, for ViZn? It's a 20-year battery. It's a 290 DC block price, right? And that DC block for ViZn is fully containerized and it does not require HVAC, right? So it's a complete DC block. Then the on-site PCS, power conversion system, the battery and inverter installation, and then the controls and the logical installation is about $85 a kilowatt hour total. That brings you to the 375. Now, I'm always talking to, whether they're analysts, investors, project investors, or developers about the price of lithium-ion modules, right? And folks are saying, well, you know, they're down around 250, 275. If I order 30 megawatts for 2018, I can get a 245 number out of this player or that player, and it just reminds me a lot of my days at Trina Solar and what was happening with solar panels at the time. And so there's a lot of discussion there. Where there isn't a lot of discussion is on the total cost of ownership of a lithium-ion system, because this is modeled for 2019. It's a 10-year warranted battery, right? So you've got a $200 price point on the lithium-ion battery, even though both Morgan Stanley and Bloomberg New Energy Finance suggest that 2019 average pricing is going to be more like $225. That being said, this is a volume buy. It's a big project. I put in 200. Well, if you look at the balance of system cost, because when you buy a lithium-ion module, the container, the HVAC, and the on-site integration of the modules into the container is not included in the price. And those are included in the ViZn price. So it's kind of an apples to oranges comparison. But for the first time, what you're starting to see is the lithium-ion module is less than 50% of the system price. The rest of the price is balance of system cost. And we began to see this trend in solar where everybody started to focus as prices came down on the modules on the balance of system costs for specific applications. And I think storage will go that way. Storage will go that way, and everybody will start to focus on all-in first cost for specific applications, and then total cost of ownership, including O&M and revenue, right? So revenue is important, right? Revenue per megawatt, and it's a huge reason why in the solar industry we've all migrated to one-axis trackers for systems that generate, you know, up to 15% more kilowatt hours per kilowatt peak per year, and why in the wind business it's all about the blades, right? Jumping from capacity factors which used to hover in the mid to high 30s to capacity factors that hover in the mid to high 40s. And so this is where ViZn really shines. Longevity, revenue, aka capacity factor, and total cost of ownership, because this price for a lithium-ion system does not include the cost of a 20-year capacity guarantee. And I can't tell you how many conversations I have a month where folks are trying to evaluate the economics of batteries on first cost only, and they're not taking into account the use case, the dispatch profile, the differences in revenues, and the cost of a 20-year capacity guarantee and the O&M agreement. We'll get into a little bit of those economics in a bit. Why are 20 years important? Well, I played a part in well over 100 utility-scale wind and solar projects, and just about every single one of those projects is financed on a 20-year term. And it's financed based on an understanding and a target IRR that a bulk of the residual income is going to come after year 10. So planning for 20 years from a utility-scale hybrid system is just par for the course. And so I've yet to see a utility-scale pro forma for any type of large renewable energy plant that is modeled for 10 years. So we took a stab at trying to understand the economics of maintaining capacity in a lithium-ion plant. And what I did was I built a forward price curve for lithium-ion modules, right? And so the price curve from now till 2021 is the average forecasted price between Morgan Stanley and Bloomberg New Energy Finance, and you can see it, and that's where the red dashed line and the blue dashed line overlap. Then two separate scenarios, one where it drops 2% year over year, one where it drops 5% year over year. And in the right-hand side here, I used a 7% discount rate, and I said, what percentage of the modules will be replaced every 5, 7, or 10 years, right? And it's a fair assumption, and it's a fair set of numbers if you ask me. And as I've been sharing this with various experts, I've been asking them, which of these numbers are most realistic, right? Which of these numbers most accurately capture what you think is going to happen? And to my surprise, actually, I've been learning that every year or so, as the lithium-ion module manufacturers come out with new modules, their impedance is different than the previous ones. Their voltage and current characteristics are different than the previous ones. And the notion that you're going to take new technology and go and swap out individual modules one for one with other modules in your lithium-ion system is challenging to a lot of experts I'm talking to. And so, the general opinion, at least from my perspective, is that you're going to be looking at 100% replacement, and that's either going to be in year 7 or year 10. And the net present value of having to replace the batteries over a 20-year cycle every 7 to 10 years is $86 to $150 per kilowatt hour in year 0. And I'm bringing that back to year 0 because I think it's important. We just looked at a previous slide where the all-in turnkey system cost for a ViZn was $375, and lithium-ion may be able to beat that. But you can't evaluate these systems side by side unless you're also in active discussions and you're open about who's owning this $80 to $150 per kilowatt hour cost and where that is and who's it contracted with.
And Mike, we're getting a lot of questions related to cost, but specifically to O&M cost. So that's something that you could touch on real quick?
Sure, absolutely. And this is a good time to do it because somebody's going to be bearing this cost of capacity maintenance on the lithium-ion side. And the ViZn system, from a capacity perspective, has negligible fade irrespective of the duty cycle. ViZn's O&M, includes our annual monitoring, where we have extensive monitoring of battery health, and we're able to understand whether or not our systems are actively balancing the battery like they should be. The only maintenance you have for a ViZn system, planned maintenance, is a trip by one technician out to every battery on an annual basis. And that technician goes and does what is the moral equivalent of checking the pH in the pool and then balancing the chemistry. That technician is not a chemist. That technician is not wearing a bunny suit because the material is not hazardous that he or she is dealing with. And it should take an hour or two, essentially, to do this maintenance on a 200 kilowatt system. So we talked a little bit about how do we get to 4 cents. Now let's talk about how we get below 3 cents. This image should be basically familiar with a lot of you, right? This is the wheel of revenue streams, and I carved out the behind the meter revenue streams, and I just kept the ISO ancillary services and the utility services in here. The P's and the E's are mine, right? And from past webinars, those of you who have been with me, we've been looking at various utility scale storage applications and use cases around the world that are gaining traction. And we've been illustrating these specific services as whether or not they're power services or energy services from the perspective of the battery. So obviously fast-moving things like frequency regulation and voltage support are power services, and then transmission and distribution, deferral, and RA or energy, longer duration use cases. As we started to look at how to get to 3 cents and below, right, we took the system that we'd already built and we started moving it around the country. And we asked ourselves, well, what if we drop this thing into Bakersfield? And we started looking at the overnight value of frequency regulation in the Cal ISO. And it's about $80,000 to $150,000 per megawatt per year. It's not enough to pay for a battery in and of itself, right? But if you're looking and you're asking yourself, what am I going to do with a 2-cycle battery when the first cycle is being used primarily for an energy capacity application? The answer for ViZn is power, right? And you know, when you just take a very conservative $50,000 per megawatt per year number, you start to look at a PPA requirement from an off-taker of 3.1 cents a kilowatt hour. You take that up to 150. Sorry, there's a typo there. That goes as low as 2.7 cents a kilowatt hour. And so, you know, these types of secondary revenue streams aren't available in all markets, but you know, the opportunity is there. Now, obviously, the solar has gone down, and I'm not your tax attorney, and I can't give you tax advice. But the key takeaway, and I think one of the main learnings that we've been gathering from the marketplace is that it is conservative to assume that after 5 years of plant operation, after the ITC recapture period ends, then grid charging is allowed, and these types of services, merchant income streams, are feasible for a battery that can do both power and energy services from a single platform. And it's not just California, right? In our previous webinar where we went through the actual dispatch profiles of various systems, both German grid balancing, peaker plant replacement, utility scale solar and wind, and T&D deferral, the opportunity to have both power and energy services from a single platform for 20 years really drives up to 1.5 times the annual income per megawatt versus lithium ion. Just one example that's sort of near and dear to our heart, right? We're working with a lot of IPPs, developers, and utilities on the California market, right? And every year there's a resource adequacy RFP. It's a 4-hour signal. The utility has committed to this being roughly 50 to 65 days out of the year. They're going to give you 24-hour notification that you need to be ready for the call, right? And so the question that we keep getting that we really like is, well, what are we going to do the other 300 days out of the year? And the answer is use the battery for merchant ancillary services and use it as much as you want, because the battery can do 2 full cycles a day, and it's there for you to use, and there are no limitations on how you can use the battery. Before we wrap it up, I thought it'd be fun to bust one myth. And this is a question we get all the time because, frankly, ViZn's footprint compared to lithium-ion systems, if you just look at a 10-megawatt system, we're bigger. We're anywhere from 30 to 60% bigger, right, in terms of how much land we use, right? And that's our wart. We own it, right? And those calculations take into account service aisles, HVAC equipment for lithium-ion, no big deal. But what's interesting is a trend that we're starting to see, right? And here what I've done is I've drawn a substation roughly 400 by 400 feet, and around it in the blue area, that's where ViZn batteries are permitted to go because they're non-flammable, non-explosive, non-toxic. And we're allowed to be inside the blue area. And what we continue to hear, and this is near and dear to my heart, I basically grew up in a firehouse. My father was the volunteer chief of the fire department for 8 years when I was a little kid. And in his office, he had a file cabinet for every large industrial facility in town. And they had a plan. They knew where the hydrants were. They knew what type of chemicals they were going to come across. They knew what adjacent fire departments from other towns were going to have to come. And they had coordinated plans for just about every facility. And on 3 separate utility scale projects recently, I've seen anywhere from a 200 to 250 foot minimum keep out area, minimum offset between the lithium-ion system and the high value grid infrastructure. Within that shaded blue area, that's about 10 acres. And ViZn can put 65 megawatts in 10 acres. We're almost done. So why is ViZn the best solution for a big problem? Very low first cost, right? Our batteries are basically 100% commodities. No special materials, no special expensive components. They're engineered and they've been third-party certified for 20 years in the field, and they can do power and energy services that leads to more megawatts per year, and it's pretty simple to go out and put them exactly where you want to put them from a siting perspective. So with that, I'm going to hand it over to Q&A, and I look forward to addressing any questions you have.
Great job, Mike. We had a lot of questions that came in, so I'm going to try and kind of group them topically. And any specific questions that we don't get to, we'll also try and possibly follow up with you one-on-one after the webinar. The one we got quite a bit is asking something along the lines of what's inside of the tank, what are the environmental impacts, what do you do with the electrolyte at the end of life, kind of all of those kind of questions.
Sure. And I actually have a handful of the slides from our Technology 101 deck with me here in the back, and I'll address the what's inside the tank question first, and then I will address the end-of-life question second. So this is the cross-section of our 200 kilowatt battery. You can see that it is 2 40-foot shipping containers. The bottom container is called the energy module. The top container is called the power module. Our CTO, John Lowell, in the ViZn Flow Battery 101 webinar that's on our website, spends a good 10-15 minutes on this slide, but also goes deeper and deeper into the technology. But basically, you have 12 stacks. Each stack is between 16 and 19 kilowatts. They're wired in series and parallel. These little blue R2-D2 guys up in the power module, those are pumps. Those are the only moving pieces in the system. The pipes is standard PVC plumbing. You could go down and buy it at the Home Depot if you want it. And the tanks are standard rotomolded plastic. tanks. And so they're inserted in the bottom container. They're filled up with catholite and analyte. Our systems ship dry, right? And so they show up on the site, and included in the price you pay for one of our systems, we send a commissioning team. We fill them up with water, KOH, NaOH, and then this compound called yellow prussiate of soda. It's called YPS. And actually, if you can buy it in these big white bags, you can buy it anywhere in the world. It's available in the specific purities and chemical compound structure that we need it in. And if you look closely at the bottom of your Morton salt jar, next time you're in the supermarket, you'll see that the yellow prussiate of soda is actually an anti-caking agent used in food. So it's a relatively benign additive. And then on the analyte side, it's the same solution, the alkaline solution, but it's a zinc oxide. And it's the same zinc oxide that's used in sunscreen. And it, like the YPS, it's available globally in significant quantities and in the chemical compounds that we require them. So real quickly, end of life, you asked. So as you could see from the previous illustration, the batteries are basically large recyclable tanks, large reusable containasPVC plumbing, some pumps, and then our stacks. They're 100% disassemblable at the end of 20 years. You can take them apart and you can feed them into various recycling and reuse streams as needed.
Okay, Mike, there were some other questions that came in basically related to discharge rate. Like, is there a limit, and what's the fastest it can discharge?
Sure. So let me, I don't have a good illustration for that, but when we talk about a 4-hour battery, that's a battery that can discharge for 4 hours at peak power, right? That battery can discharge at roughly twice the duration at roughly half the power, or 1/3 of the power for 3 times the duration. So the fastest you can discharge our battery is in 4 hours at peak power.
And relatedly, a number of people kind of hit on the 2 cycles per day, like asking if that was some sort of a limitation.
It's not a requirement at all, right? The battery itself can do 2 cycles a day. It's important to consider the second cycle as you're looking at additional revenue for a particular project. And I'll just jump back to the key slide here in this utility scale system, right? There's whether it's a large industrial system, a commercial system, a municipal system, or a utility scale system like this, there's lots of use cases and lots of potential revenue streams. So the second cycle gives you an opportunity to look for additional ways to use the battery. The conventional thinking around trying to make a decision on when to discharge or charge a lithium-ion based system kind of gets thrown out the window, because this battery likes exercise. It likes to be charged, it likes to be discharged, and it's constantly looking for something to do. And so we find that we're most competitive when you can take the 8760 hours in a year and try to use the battery for as many of those hours as possible.
And while you're on that slide, there was actually a few questions around how difficult is it to switch from power to energy services, or how long does it take, stuff like that.
Yeah, all of that power conditioning is done in the power conversion system. It's below 20 microseconds. We're able to do high power services like frequency regulation or peak charge reduction at all the way from 5% to 95% state of charge. So there really are no limitations on deploying the battery for power services while you're doing an energy service. And we kind of call that walking and chewing gum, that you can be providing for, let's say, a large industrial client, a type of bulk energy integration or time of use bill optimization or a demand response opportunity. And you can stop, and if it makes economic sense to do that, go after a peak charge reduction.
I had quite a few questions related to inverters. Just wondering if there's any kind of limitation on inverters that can be used. So if you could touch on that.
Sure. So time and time again, when I've been just talking to customers and talking to clients, folks talk about their first energy storage project. And what I consistently hear is that, the battery's working great now, the returns are in line with what we expected, but man, it took 3 to 6 months for the system to get fully integrated on site. And so the old adage, spend, $1 in the shop or $1 in the factory to avoid spending $10 in the field, rings true here. So not just Schneider, but several other power conversion systems manufacturers and ViZn have come together over the past 2 years, and they've invested heavily in shipping us their power conversion systems, and we've pre-integrated solutions for 3 or 4 different manufacturers and 3 or 4 different controls providers as well. Depending upon the system that you're looking at, we'll give you several options. In addition, every week or so we get contacted from a new inverter manufacturer, and we're able to look at the match between our voltage and current and their products, and we're able to determine pretty quickly whether or not there's a good fit. And so we're open, we're collaborative when it comes to additional power conversion systems, and it's something that we work on every day with our customers.
Okay, Mike, quite a few people seem to be familiar with vanadium as a flow battery chemistry. So could you just compare, ViZn chemistry to vanadium?
I knew this was coming. Let me go to the slide real quick. So there are several different flow batteries out there, right? There are alkaline-based flow batteries like zinc's system. Then there are acid-based flow batteries like vanadium and zinc bromide. Then you have systems that are considered to be liquid-liquid and others that are considered to be liquid-metal. And as you kind of look, there's maybe 8 or 9 companies in the space that are actively shipping systems now. There used to be a few more, right? But it's important to think about as you go from left to right and top to bottom what the impacts are. I'll start with alkaline-based versus acid-based, right? So when I talk about our standard rotomolded tanks and PVC plumbing and standard pumps off the shelf from the semiconductor industry with standard impellers, we're able to use those types of standard commodity type materials because we are alkaline based. To the extent you are acid based, where your primary ingredient is H2SO4, you're in a situation where all of those tanks and plumbing and pump impellers need to be manufactured by materials that can live in a highly acidic environment, and that really adds cost, right? The other thing that really adds cost is the vanadium-based chemistry. My chemistry, which we showed you earlier, is water and commodity powders and some alkaline chemicals that are available globally in the compounds that we require them. We start to look at vanadium, and the cost of vanadium and the cost of the vanadium electrolyte, in addition to the cost of the packaging and the tanks and the plumbing that I mentioned, can lead to all-in turnkey system prices that are 20 to 30% higher than ViZn's system. So I'm talking today about a 30 megawatt system that we're committed to deliver at $375 turnkey in 2019, and I would position that a similar vanadium system of the similar size would be 20 to 30% more expensive turnkey because of the cost of the electrolyte and the significant cost that being acid-based has on the balance of the DC block architecture. In addition, as you start to go towards liquid metal, the abilities of the batteries to drive power without losing capacity is a big value add.
Okay, Mike, the most popular topic in the questions by far actually was round trip efficiency. People asked that pretty much throughout the presentation, so I think that's one we should definitely touch on.
So it's important. It's important to think about round trip efficiency. We get this one every time, right? And it's important to think about round trip efficiency in energy storage like a dynamic number, almost like your car, right? When you're going pedal to the metal with a lithium-ion battery, your round trip efficiency drops off pretty quick. When the lithium battery is outside of its desired state of charge window, the 40 to 60% state of charge window, the round trip efficiency drops off pretty quick. When you are running a lithium-ion battery in an ambient temperature that's either hot or cold or super hot in this type of application, you start to run your heating, ventilating, and air conditioning systems pretty darn hard to extract the heat and to keep the battery cells themselves within a tight temperature window. And so ViZn system is different. ViZn system is relatively flat. We don't have any HVAC, and it's relatively planar in terms of the round trip efficiency. And when we talk round trip efficiency, we mean AC round trip efficiency, including all auxiliary loads, right? And it's actually one of the most frustrating pieces of specsmanship that I'm seeing in the across battery vendors, because folks aren't being straight about what to expect from complete system performance, because they're either not including auxiliary loads, they're not including losses in the inverter, so they're running around talking about round trip efficiencies in the 90% range. Well, if you go and you talk to any system integrator of lithium-ion systems, they'll tell you for an AC, meaning the power has to go in and out of the inverter, for a system that takes into account all aux loads for a hot climate site, lithium-ion AC round trip efficiencies are actually in the low 80s. I've heard numbers as low as 79, numbers as high as 74. For the purposes of this illustration, I'm going to use 82%. So 82% for lithium-ion, 74% for ViZn. Right? So that's an 8% spread in round trip efficiency. So let's take a look at what that means for this actual system. Right? So starting at the top, 30 megawatt system, 4-cent PPA rate, 120,000 kilowatt hours into the battery, and an annual solar production that's on a daily basis 602,000 kilowatt hours. So only about, for a single cycle, only about 20% of the plant output can go through the battery, right? So then if we consider round trip efficiency losses as lost revenue, lost kilowatt hours per day, the ViZn system loses about 31,000. The lithium-ion system loses about 21,000. And taking the difference, or the net present value of that lost revenue over 20 years, that's 455,000 versus 315,000 on an annual basis, and the net present value on a dollar per kilowatt hour basis is 38 versus 26, or $12 a kilowatt hour. Now, this $12 per kilowatt hour is nothing to sneeze at, right? So that's about $130,000 difference per year. But this is a utility scale system who has revenue streams that range between $8 and $11 million a year. So this is a small impact, right? And this net present value of $12 per kilowatt hour, when we go back, if we go back and we look at the potential expense of a 20-year lithium-ion capacity guarantee that the owner of the project is going to have to bear either through a capacity contract or an O&M contract or internal lithium-ion module changeouts, it's anywhere from, well, it's up to 14x smaller than the impact of that capacity guarantee on the owner's economics. Because we, as we saw earlier, that was about $143 a kilowatt hour at its peak. Are there more, Matt?
There's a lot more that probably need to be handled offline because they're very specific, and we're also coming right up to our 2 o'clock end time.
All right. Well, hey, thank you everybody for attending. It's been a great session. We're available for questions, follow up today. Don't be shy. Look forward to seeing you on future events. Thank you.